the quiet heating system that worked without electricity. During the 1940s, entire neighborhoods were heated by a principle so simple that, honestly, modern houses rarely use it anymore. No fans, no pumps, no thermostats, no electrical components at all. Yet these systems warmed entire homes, often more evenly and more reliably than many heating setups used today. The principle was thermal siphoning, also known as natural convection heating. Builders during the wartime era understood something modern construction frequently ignores. Heat naturally moves. Warm air rises. Cooler air sinks. When structures are designed around that reality, the building itself becomes part of the heating system. This was not a luxury innovation. It emerged from necessity. The early 1940s were defined by material shortages, electrical limitations, and the logistical demands of global war. Builders had to design homes and barracks that could remain warm during winter, even when power was unreliable or unavailable. The result was a quiet engineering solution hidden inside walls, chimneys, and floor cavities. Homes used convection channels, heavy masonry, and carefully placed vents to circulate warmth automatically. In many cases, a single stove could heat an entire structure simply because the building had been designed to move heat on its own. For modern viewers who are used to forced air furnaces and electrical heating systems, this approach can seem, well, almost primitive. But in reality, it was an elegant combination of physics, architecture, and survival knowledge, one that still offers us some valuable lessons today. Wartime shortages really forced builders to rethink how heat could move through a house. The Second World War dramatically reshaped domestic construction all across North America and Europe. Steel was diverted to military production. Electrical components were prioritized for factories and communications networks. Fuel conservation campaigns were pretty common. Under those conditions, heating systems that required pumps, fans, or complicated mechanical parts were not ideal. Simplicity mattered, and reliability mattered even more. Builders began relying on passive heating strategies that required little maintenance and could function regardless of power availability. The goal was to design structures where heat would circulate naturally through the building envelope. Thermal siphoning works through a straightforward physical principle. When air is heated, its density decreases, causing it to rise. Cooler air, being denser, sinks downward. If a structure provides pathways for that movement, warm air will climb through the building while cooler air returns to the heat source. The cycle repeats continuously. In a well-designed structure, this process can move a surprising amount of heat. The system never turns off because the physics driving it never stop. During the 1940s, architects and builders integrated this principle directly into floor plans. Stoves were positioned centrally, vertical air channels were hidden inside walls, floor grates allowed warm air to rise into upper rooms. Instead of forcing air through ductwork with electric fans, homes allowed heat to travel the same way smoke rises through a chimney. The result was a quiet heating system that could operate day and night without mechanical assistance. Heavy building materials quietly stored and released heat for hours. Another overlooked feature of 1940s heating systems was the deliberate use of thermal mass. Builders relied heavily on materials such as cast iron, fired clay, and brick. These materials do something modern lightweight construction rarely replicates. They absorb heat slowly and release it gradually over time. So, cast iron stoves are a clear example. When heated, the metal absorbs a significant amount of thermal energy. Even after the fire dies down, the stove continues radiating warmth into the room. Brick and masonry behave in a similar way. Walls and chimneys made from dense materials act as reservoirs for heat. As the stove operates, those structures absorb warmth. Hours later, they release it steadily into surrounding rooms. This effect stabilized indoor temperatures. Instead of dramatic swings between hot and cold, rooms warmed gradually and cooled slowly. In many wartime homes, chimneys were positioned intentionally so that multiple rooms shared contact with the same masonry structure. The chimney itself became part of the heating system. As hot exhaust traveled upward, the brick absorbed energy and radiated warmth outward through interior walls. Builders understood this process intuitively, even if they rarely described it in scientific language. A well-built masonry chimney could contribute more heat to a house than many modern radiators. Convection channels quietly moved heat from one room to another. The most fascinating part of these systems was often hidden inside the walls. Convection channels, essentially vertical air shafts, were sometimes built between rooms or inside chimney structures. These channels allowed warm air rising from a stove room to travel upward into other parts of the home. At the same time, cooler air from those rooms would sink through separate pathways back toward the heat source. This created a self-sustaining circulation loop. In certain 1940s homes, simple floor grates above the stoveroom allowed warm air to rise into bedrooms or attic spaces. Small return vents near the floor let cooler air fall back down. No fan powered this movement. The temperature difference alone, honestly, created the airflow. Military barracks built during the war frequently used similar techniques. Heating multiple rooms with limited fuel really required efficiency. Central stoves, combined with vertical air channels, allowed a single heat source to serve dozens of occupants. These systems also had an unexpected advantage: silence. Without mechanical fans or pumps, the heating process produced almost no sound. For households accustomed to the rumble of modern furnaces, the difference would be immediately noticeable. Modern heating systems often sacrifice efficiency for speed. Modern heating systems really focus on making temperature changes happen fast. Forced air furnaces push heated air through ducts using powerful fans, and radiator systems use pumps to circulate hot water quickly. These systems definitely get the job done, but they depend on electricity and some pretty complex mechanical parts. When the power fails, well, the heating system often stops completely. The older convection-based systems, though, operated in a different way. They prioritized steady warmth rather than rapid heating. Since masonry absorbed and released heat slowly, rooms stayed comfortable for longer periods, even after the fire burned down. The system acted more like a thermal battery than just a simple heater. Another difference actually involves air movement. Forced air systems circulate large volumes of air quickly, and that can create uneven temperatures and drafts. Natural convection systems move air slowly, and the result is often a more stable indoor climate.